Welcome everyone, a pleasant afternoon to all of you. Thank you so much for joining us today. If this is your first time to join our NRW webinar series, a warm welcome to you. So we are now on the third leg of our three-part webinar on non-revenue water strategies from the specialists. So for those who are able to join us from the last two parts of our NRW webinar, I hope that the topics on the introduction to NRW by Ryan Paul Bacolinaw and also the flow and pressure data management by Gary Wyatt were able to help you deepen your knowledge on those areas. So again, my name is Karen Samante. I'm the co-founder and the digital operations and marketing manager of AJA Marketplace, and I will be your host for today. Together with me as a co-host is my colleague, Jamae Jimenez. She will be helping me out facilitate on the latter part of this webinar. So before we go further, let's just do a little housekeeping. So again, as you can see, there is no microphone or camera functions on your Zoom's control panel. That is because we are in a webinar mode. However, if you have any questions during the presentation, please type in your questions into the Q&A button you'll see on your Zoom control panel. Also, please refrain from asking questions which are not related to the topic. So participants will also receive webinar certification. You might have questions about the certificate. Jamae will discuss that further, so please make sure that you will stay tuned until the end of this webinar. So the webinar recording, also the copy of the presentation slides are now available in AJA Marketplace. That's for the first two parts, okay? So after this webinar, for sure, we will update that and include the recording, presentation slides, and also the answers to the questions which will not be addressed later on this same website. So just click on webinar, you'll have a drop down, click on webinar videos, and it will lead you to this page. So the presentation proper will be 45 minutes long, and after that, you'll have a short break. And after the short break, of course, you'll proceed to the 15-minute question and answer portion. So our three-part webinar is presented to you by AJA Marketplace. AJA Marketplace is a multi-vendor online website wherein you can request for quotation for the products you need for your water projects. So this is like Shopee or Alibaba, if you're familiar with those online platforms. However, this is mainly focused on the water sales and wastewater sales and services. So currently we have around 11 categories available for water utility providers which are under the government sector. This can be used for shopping and the small value procurement. So this will be a great help, especially for the end users, for the purchasing, because this will really help their procurement process more convenient. And later on, I will show you a video about this platform to know more about it. So this platform, AJA Marketplace, and of course this webinar we are conducting right now, is initiated by our CEO and co-founder, Mr. Alan Gueda. This webinar is also in cooperation with Philippine Works Association, Philippine Association of Water Districts, and Water Environment Association of the Philippines. Of course, it is in special participation with water law specialists from International Water Association, or IWA. So now let me introduce to you our speaker for today's topic on Introduction to Leakage Detection. So our speaker for today is a qualified civil engineer, environmental engineer, and a chartered manager, having studied at Northampton and Huntingdon University in the UK. So he started working in the water industry in the 1980s, where he spent 14 years with Anglian Water, prior to leaving to set his own company up working in NRW. The company employed over 200 leakage engineers working mainly in the UK. So this company was acquired later on in 2007 by a UK water company and then went on to own a technology company before joining Mia Water as the Director of International Business Development, where he worked where he has worked in over 30 countries. Aside from what I've mentioned, our speaker has written many papers and has also authored 4 books for the IWA, all on NRW, with his last one released earlier this year as the updated version of the book, Leakage Detection. He's also currently the chair of the IWA Water Loss Specialist Group. So let me give the spotlight now to our speaker for today, Mr. Stuart Hamilton.
So without further ado, I'll start the presentation. So as we said, we're going to look at leak detection equipment. Comes in many forms, but people look at leak detection and think, what is it? Well, this isn't leak detection. These leaks find us. We don't need to go anywhere to find them. They pop out the ground, they get reported. Normally reported straight away. These are not the problem. If only it was this easy as well. If only leaks were this easy, that they just pulled out the ground and we found them. But again, they're not. We all know they're not. But we have to go and find them. Now, how would we find them? We find them in many different techniques, methodologies, and many countries around the world do them differently. But all the time we need to go and find them. And we only have so many tools. We don't have everything. We're not Superman. We're not Superwoman. We are just a normal person. And this is what people need to understand, that we are just normal people. We don't have X-ray vision. We cannot see through the ground. We cannot see what's going on beneath the ground. Technology today is beginning to get us towards this dream, but currently we are not there. So in effect, what are we? Or what are you? People that do leak detection. What are we? We're just ALFs. We call them ALF. It's just an average leak finder. So when we look at how does he find leaks? Well, his only chance is he has to go to detect leak noises. He randomly goes, walks the streets to find a leak noise to see if it's a leak. Or if it's a leak noise. What does he need? Or what does she need? Because, you know, leak detection engineers now come in all sexes, all shapes, all colours. It doesn't matter. But what they need is equipment, training, and commitment. Now, this needs to come from the water company itself, because the ability is there, the wanting to learn is there from these leakage engineers, but they can't be trained themselves. They need to have the correct methodology, the correct tools, and the correct training. So this is basically understand now what we are and what we call an ALF is, just an average leak finder. They're not special, they're not engineers, they don't need to go to university. What I always say is that with a leakage engineer, you can do it or you can't. Education doesn't come into it. You can be really low educated, but have a fantastic ability to find leaks. You can be super educated and not one idea at all how to find leaks. So education doesn't come into this. This is ability to be able to understand leak noise. So when we look at leak noise, the problem is there are many causes of leak noise in pipelines. People believe we just listen to the pipeline and hear a noise, that's a leak. No. Consumption, pressure reducing valve, obstructions in the pipe, closed valves, changing pipe diameters where the velocity changes cause the noise, pumps, electrical interference, gas compressors, air conditioning units, refrigeration units, electric pump stations, lamppost lighting in the street. All these create a noise. And all these create the noise the same as what a leak noise creates. So we have to go out and understand, when listening for leakage, is it actually a leak noise, or is it one of these other elements that also create a noise? And again, we can't train somebody to say, read a book and understand this. This comes with experience, and this comes with time. And it comes with error. You will make the mistake once and get caught out. Hopefully you don't make the mistake twice. So now we look at that. Now we look at material types. Hope these material types are the things that majority of the world has in their distribution system. We have steel pipes, iron pipes, copper pipes, asbestos cement, concrete pipes, lead pipes, PVC pipes, polyethylene pipes. So whether you've got one of them, they are what generally are in the distribution system. And the problem is that the non-metallic leaks, or the non-metallic pipes, do not transfer leak noise very well, whereas the metallic pipes transfer leak noise very well indeed. And a way to explain this concept is that if I have a length of copper pipe and it's 4 meters long, and somebody sits at one end of the pipe, and at the other end of the pipe I tap the pipe, the copper pipe, the person 4 meters away will hear that tapping on a length of copper or steel pipe. If I do the same with a length of garden hose, a length of plastic flexible garden hose, and I tap like so, the person 4 meters away will not hear the tapping noise. And the reason is the energy at the start, which is the tapping, is the same as the leak. It's energy. A leak noise is energy. On a steel pipe or a metallic pipe, that energy is transferred down the material because it's hard, which is very good. On a non-metallic pipe, that energy is absorbed into the pipe, which means the leak noise doesn't travel. Now, this is a very simple concept of understanding it, but you can understand now that when you do leak detection on a steel or metallic system, it is different to doing leak detection on a non-metallic system. Now, this is again what we have to learn as engineers, and we have to decide the process. Other things that affect us. Pipe material we just looked at, is it hard or soft? Pipe diameter. This affects it because on a large pipe, that energy has the cross-sectional area of the pipe to be absorbed into. Whereas on a small diameter pipe, it isn't absorbed into the cross-sectional diameter, the surface of the pipe. It isn't absorbed because it's very small, so it can go the distance. On a large diameter pipe, a very big pipe, the energy is absorbed around the pipe, so therefore it doesn't travel so far. So this is irrelevant of material. So diameter of pipes are different. And this is when we're listening on mains fittings for leak noise, not when we're listening above the surface. So all these are when we're listening on the fittings to hear if there's a leak noise present. Pressure. Pressure is different. If we have 1 meter pressure or 60 meters pressure, the energy from the leak will increase with higher pressure, which means the energy will be greater, which means it can be transferred further down the pipe. So again, this is common sense. But if you've got 3 meters pressure, as you do in many places in Asia, and you're listening on a 500 millimeter pipe, and you are 300 meters away from the next fitting, you are not going to hear the leak. If the leak is even there, you will not hear it. Now, these are common mistakes that people have when they don't adopt the right approach or methodology. Background noise, like we've mentioned earlier on, obstructions, PRVs, any noise that creates a noise on the pipe will make you think there's a leak, or it could even mask the leak, so preventing you from hearing that leak because there's another noise there that is greater. Consumption, whether it's domestic or industrial, will always have an effect, because if you go to an area which is an industrial area and you're doing leak detection and water is being used, you will hear velocity down the pipe, and in hearing velocity down the pipe, you will also at the same time you'll hear the meter ticking as well. So the meter will be going around, so that will affect you as well. So all of this means that the best time to do leak detection is when the noises are at a minimal and the pressure is at a maximum. So this is common sense. And when is that? Generally, it is between the hours of 1 o'clock in the morning or 2 o'clock in the morning till 6 o'clock in the morning, before traffic gets back on the road. And this is why we do leak detection at night in busy areas. If we're in villages which don't have high traffic usage, we can do them areas during the daytime. So again, we need to understand when we will do our leak detection. When will we start? Another common error is we do not choose the right time to do leak detection. And one more thing to think about when we do leak detection, we need to ensure we do leak detection when you have water in the main. Again, you may not think this is common sense, but I have seen it before where people have intermittent supplies and yet they will conduct leak detection activities when there is no water being present in the pipes. And you think, wow, that is ridiculous. I have seen it. It's happened several times, because people who do the leak detection are not aware when distribution is putting water into the system. Again, something to look for. So when we look at leak noise, what is leak noise? Leak noise is constant. What do we mean by this? Leak noise is constant. That means that no matter what, every time you go back to that pipe, the leak noise will be there. If it's background noise, the noise will come and go depending on when usage or whether the electrical interference is being on or off. That is the difference between leak noise. Leak noise is always there. Leak noise travels through the pipe wall and in the water. It travels in both directions, and the further from the leak, the weaker the noise. So again, it travels in the pipe wall and in the water. If the pipe wall is soft, it travels a smaller distance in the pipe wall, but it will still travel in the water the same distance as regardless whether it's metallic mains or non-metallic mains, when it's leakage and it's traveling through the water, that is a different scenario to when we do leak detection, listening to the pipe wall, or listening to a valve, or listening to a hydrant, or listening to a stop cock, a service valve, or health connection. The quality of leak noise is dependent on types of material and the ground that is around the leak as well. So the ground now can influence the noise from the leak. If the ground is a very hard ground with clay, although there's a leak there, the clay ground surrounding the pipe actually forms a pressure in that pipe, in that clay area, which means the noise or the water from the leak doesn't leak very much because it's being pressurized within the ground around the pipe. Now, this is difficult sometimes to understand, but if it's a very stony, loose area around the leak, the water can just leave the pipe and go into the ground. So again, there is a situation where the ground can change the ability to hear the leak. So all in all, metallic pipes, good noise, high frequency noise, good to listen to. Non-metallic noise, non-metallic pipes, poor noise, low frequency noise, very difficult to hear leaks on. So just to go over this again, what is good quality? Nice high water pressure, good pressure, 20, 30, 40 meters pressure, very good for leak detection. A good hard backfill, which lets but stony, which means it lets the water leave the pipe. A small hole in high pressure will cause a very high noise, a high amount of energy to leave the pipe, and that's good for leakage. A clean pipe, if the pipe is clean inside, it means the ability of water can transmit it and it doesn't cause any obstructions in the pipe that can cause a background noise. Metallic pipe, small diameter. All of them is good for leak detection. Now look at what is poor quality for leak detection. Okay, low water pressure, soft backfill, poor backfill material. Not just little holes in the mains, split in the mains, blocked up pipes, non-metallic pipes, large diameter. Now, the problem is that where we see poor quality, low pressure, Asia and a lot of the Asia regions. That's low pressure, okay? Non-metallic pipes. You have concrete pipes, you have lots of plastic pipes, yeah. Large diameter pipes, meaning above 300 millimeters. Yeah, you have them. So your ability in Asia to hear leaks and do leak detection is even worse. In England, in the UK, in the USA, we have smallish pipes, we have good pressure, we have good backfill. We had a lot of metallic pipes in years ago. Leak detection was so easy. So when you see people from the UK as expats come out and say, oh, leak detection is easy. It is easy in the UK because we have the perfect scenarios. We did have, now we have lots of plastic pipes. We did have the perfect scenarios for easy leak detection. So when we look at, just to put that into practice, we have a leak on a pipe. And this leak, so we have pressure in the main and the leak on the pipe. Energy from that leak is transmitted through the water, and it goes through the water for a long distance, further distance than on the pipe wall. But at the same time, energy goes through the pipe wall as well. So it's in the pipe and on the pipe wall. So when we look at pressure in a pipe, a small leak can happen because in a pressurized pipe, a small leak doesn't cause any issues to you on a pressure drop. So the small leak doesn't matter. So small leaks can happen everywhere and run for very long periods of time, and we won't even know they're there unless we monitor the system. And this is monitoring through the system through DMAs or metering or some other method of finding them leaks. So small leaks can run for very long periods of time. Whereas a catastrophic burst, a big leak, which people think are problems with leak detection, are not, because what happens? The pipe fails, it bursts, it causes a catastrophic failure, pressure is lost immediately in the pipe, people are aware there's a leak, water comes to the surface, generally, or water will gush somewhere, and you'll find that leak sometimes within maximum 1 or 2 days. So that's not a problem. So where people think the big leaks are problems to leakage engineers, they're not, they find us. So this is the difference. We have the problem with the little leaks. So now we're going to look at a quick look at how do we do a leak detection survey. What do we do? We've got several methods we can use. We're going to look at the processes called LLP, localize, locate, pinpoint. We have optimum and we have basic. We'll quickly go through each one of them so you can understand the principles. We're going to start with localize. We have 2 techniques, all fitting surveys. We listen on every fitting, every tap, every valve, every hydrant, every house connection, every outside tap, everything we can see, we listen on. It's consuming, it takes longer, but it works on all mains materials. And although the lower the pressure, you need to be listening closer to the leaks or closer to the fittings so you have a chance of hearing the leak. Mains fittings only, you only listen on a sluice valve or a fire hydrant. It's quicker, you'll miss all the small leaks, you may get the burst mains depending on the pressure and the ability for the leak noise to travel to that fitting, and it's only good for metallic mains. So now looking at that, mains fittings only were something I started with in 1980, 1981, when I started doing leak detection with Anglian Water, because we had metallic pipes, 100mm 4-inch pipes in the ground as average, very good pressures, 30 to 40 meters pressure, and I could hear a burst main 300 meters away. Today, not a chance. We go back to all fitting survey. Here we are doing it now. You can see the lady there just listening on the hydrant. This is in Canada. And she listens to everything she can find with an electronic listening device, not with a manual listening stick. We also have noise loggers. This is localized as well, noise loggers, and we have district metered areas. Now, we can have district metered areas with noise loggers. We can have district metered areas with sub DMAs within there. There's different scenarios. So basic version is just listening, then noise loggers in a lift and shift method or moving, or district metered areas with noise loggers involved as well. But a noise logger is what it looks like, just being put onto a fitting. It doesn't listen to leak noise. It listens to all noises. So it's not just noise, it's a noise logger. It listens for constant noise. So this is different. People think, oh, it's going to find the leak. No, it will listen to every noise. Long battery life, 5 years, very simple to install. You can program it to wake up at different times. So if you're on intermittent supply, you can work that out. It can be installed during the day, and you can tell it to wake up between 2 o'clock, 4 o'clock to see what's going on. See the size of it, quite small. All the manufacturers now make these. They're not specific to any one manufacturer. Ideally on metallic pipes, you want to be no more than 250 meters apart. And because leak noise will travel in both directions, this will listen 125 meters either way. So if they're all 250 meters apart, they will cover 125 meters either way, minimal, and they will also do an overlap. When we get to plastic pipes, non-metallic, they need to be set much closer. Don't go any more than 80 meters apart on a non-metallic main, which means the noise logger only has to hear the leak 40 meters in either direction. And that's even if the leak noise will travel. So depending on your pressure, you need to understand how far you're going to put them apart. And when you look at the basic loggers, when you download them, the logger with the closest to the leak will show a bigger peak. That's all you need to understand. You have got advanced correlating noise loggers, which is a different thing altogether. So again, you attach them to your fittings, main service connections. Tell it to wake up when your system is the quietest. You can leave them in situ permanently, or you can pick them and move them on a daily basis. They're available to be downloaded manually via a link, a radio link. You can connect them now to a cellular network where it comes in through your wireless or your telephone network, or you can have your own wireless network as some countries do, and it can come in over that network as well. They all come in different ideas. Basic version, just by drive-by or picking it up and downloading it manually. And what it does, it gives you a cluster. If you're just doing it in the basic version, it will basically, you get it up, you plot it, and it just gives you clusters. It tells you where the cluster of noise is. And that is where you go to look. So if you look on this map, I don't know if you may not see it properly, see lots of areas of green, which are areas which are clear of leaks or clear of noise. And then you can see areas of red, which means we had an indication of a noise. So now I only need to send a leakage engineer to them 3 regions within the city or within the town. Now with noise loggers, you don't need a DMA. You can deploy them openly into a system because it's not using a DMA methodology for planning. We do step testing now. Think about step testing. It's basically where we systematically isolate the network by turning valves off independently to turn off the flow into a small area of pipework. And we monitor the flow going through the meter. So as we systematically turn off the areas, we monitor the drop on the meter, and therefore we can see which area has the highest drop. We have to understand in that area the consumption pattern and how many properties are on that drop to ensure we're not turning off in one step 100 properties, on the next step 1,000 properties, where we would expect a larger drop in flow because we feed in a lot bigger or a lot more properties. But again, this is when you do step test training, you will learn it and understand. So here we are, step testing principles, flow meter. We enclose the area because we're now within a DMA. And what we do, we go out and we set the flow meter up, we put our meter on there, and we read in what is happening going into the area. And we start to turn off areas of the network bit by bit. And we monitor the flow. And if you can see on the graph, as we turn each one down, we can see how much water is being turned off or stopped in each step. Now we can see, looking at that in step number 7, that is where it's a bigger area than others, which is fair, but it had a significant drop in compared to all the other areas. So now we only need look at the region in step number 7. And if we wanted to, if that was a large area, we could do another step test within that step number 7. And it will tell us which street then the leak is in. So you can use this if you've got a big leak with no leak noise and you don't know where to start looking. Quick look at locate. Locate is a correlator. A correlator does not pinpoint the leak. A correlator gives you an indication of where the leak is. And as noise loggers before, you do have such a things as correlating noise loggers as well, which is much the same usage as a correlator, but will be left in situ for longer periods. So again, our pipe, we find we have a leak. We go out there with a correlator and we deploy our 2 boxes. And it doesn't matter whether it's red and blue, red and yellow, A and B, 1 and 2, there's always 2 boxes. You measure the distance between the boxes going along the length of the main and the fitting, between the fittings. So you need to understand the length of pipe work. And you input that data into the correlator. At the same time, you understand the pipe diameter and you understand the pipe material. So what we do, we enter the diameter into the correlator and we enter the material into the correlator. And then the correlator has a preset of tables, and in them tables it tells them the velocity of sound down that pipe wall based upon the diameter and the material. And we know the distance, so we put it in, and the correlator basically does a time delay between the red box and the leak noise and the yellow box in this instance and the leak noise, and it does a simple calculation and tells you where the leak is. So it's just velocity or distance minus velocity times time delay divided by 2. So this is what the correlator does. We must know the distance, we must know the diameter, and we must know the material. If we don't guess any of them, the distance is wrong, the leak position is wrong. The pipe material is wrong, the velocity is wrong, the leak position is wrong. The diameter of the pipe, the velocity is wrong, the leak position is wrong. So when you look at correlators, how they've progressed, if you look at the left, the big yellow one, that was a correlator that I used back in the 1980s. And if you look at today, the correlators now can come onto a mobile phone. So that's much more progressed. And there's probably more operating or available knowledge in the little correlator, the handheld, palm-held correlator, than what there is in the big one that we used many years ago. So again, if we just look at a screen from a correlator, look at a screen, you can see on there, we put the distance in, 259 meters. We put the pipe material in, and we put the pipe material and the diameter, which gives us as a velocity down the pipe of 1,110 meters per second, or 1.11 meters per millisecond. We don't have to calculate that, we just need to put the material in, it tells us that. Based on that, it's calculated the time delay from the blue of 58.93 milliseconds. We don't need to worry about all this. We just need to worry about we've got the distance, the pipe material, and the diameter correct. And it tells us on this instance, 162.5 meters from the red, it throws a peak up, and the peak indicates in that position, if all your data entered is perfect, that is your leak position. If it's not perfect, you can be within 5%, 2%, 10% of that position depending on how accurate your data inputted is. So this is why it's only a locator, not a pinpointer. You can go to mid-range level. Basically, you have two boxes, A and B, 1 and 2, red and blue, red and yellow. It doesn't matter. It doesn't matter where you buy them from, as long as they're all the same basic two-box systems. They're all much the same as each other. They all work the same. They all use the same theory. They all use the same formulas. Nothing changes. And there's not probably one now that is better than other. I always suggest that if whatever one you purchase it based upon the ability to have the support in your country or your town or your city. Don't buy one that has no support anywhere and it's only on phone calls or people having to travel to come to see you for flights to answer a question. Let's look at pinpointing. What is pinpointing? This is when we're going to actually tell you where to dig the hole, the exact position of the hole. And what happens is, you got your pipe, the pressure's inside the pipe, you suddenly have a leak. And that leak noise goes through the pipe wall, through the water, and also transmits to the surface. In transmitting to the surface, we walk over the line of pipe and we listen for that leak noise. And where that leak noise, for ease, is where it is loudest, is where you are possibly over the top of the leak. As we said before, the material of the backfill will affect the ability for the leak noise to come to the surface. The pressure in the pipe will affect the ability for the leak noise to come to the surface, because if it's very low pressure, the leak noise will not travel to the surface because it's not leaking out the pipe very much, therefore it's a weak noise, it won't travel. But in reality, the size of the leak will make an effect, but the pipe material and the diameter won't make an effect of the leak noise coming to the surface. It's the leak type and the leak size and the pressure and the backfill. Diameter and material is not affected on pinpoint and leak. So we do that when it's best done at night, when it's quietest, when there's no background noise, when you have no traffic up and down the streets. That is when you do your best pinpointing. And pinpointing is when you actually pinpoint the position to do the leak position, to do the excavation. So we localized it in a region by step tests and brought it to a region. We've located an area of the leak with a correlator or with something, and we have now pinpointed the position of the leak. So with pinpointing, we have various techniques. We have the conventional listening stick, a metal listening stick, an electronic listening stick, or the ground microphone. The ground microphone or the electronic listening stick is what you should always use. Do not use the metallic or the wooden basic listening stick. You will miss more leaks than you find. So looking at this, I mean, the reason being that the noise is amplified and you'll get a greater sound up, and the noise can be, the background noise can be somewhat hidden. But always use the electronic device, and if possible, use an electronic device that has an indicator on it for sound. So if you can't hear the difference, the indicator on the display will tell you whether the loud's higher or lower at that point. So now we're looking at what should I buy? Do you need noise loggers? Do you need correlators, or just need listening sticks? If you're starting at the beginning, you need just a basic listening device, an electronic listening device. But are you metallic or plastic? What are your mains? Do you live in a city, or is all your area urban or villages? Is it busy in your city or busy in your town? Do I have DMAs or no DMAs? Have I got lots and lots of leaks, or do I have just a few leaks popping out every now and again? Do I have money? How much money do I have? What can I buy? What resources do I have? Do I have teams? Do I have anybody? Have I got a section? Or do I have 20 people available? And the other thing is experience. What experience do you have with your staff? So do not go out and buy a correlator as the first point of call when you've got the wrong system, you have no experience, and you're short of funds. Always start off with the electronic microphones, ground microphones. So again, just looking at it, what should I buy? First level, second level, and third level. Majority, your first level. You need a ground microphone or an electronic listening stick. When you have them, you get good, you understand. Start to look at correlators or noise loggers or something different. And when you really get good, you can start to look at advanced leak detection technologies. So that's just a basic introduction to leak detection. So now I'm just going to spend the next 10 minutes just going through a case study that was done, and to explain, you'll understand at the end of this why you do not do leak detection with manual listening sticks. So first of all, let's look at the human ear. When you were born, your hearing was perfect. So when you're a little baby, your noise, the hearing is perfect. As you get older, your hearing starts to deteriorate. And normally when the age of 8, it starts to deteriorate quicker because you're starting to listen to louder noises. Now, what this effect is having, if you look at your children on their Xboxes or their electronic devices or listening to music through their headphones, which is quite loud, they are damaging their hearing. Their hearing will never ever come back to what it was. So what happens is, depending on whether you listen to loud music or what you listen to, your hearing decreases or gets worse with age, and gets worse quicker or slower depending on what you've done in your younger days with music, concerts, or playing games. So what happens is, you're a young adult, your hearing has dropped from the 20 hertz of the high, the lower 20 hertz, or the high of 20,000 hertz. When you're a young adult, you drop to 16,000, and at 30 years of age, you're down to 12,000. These are 12,000 hertz. This is your ability to listen for a leak. And your low range of 20 hertz is probably now higher, and you can only hear leaks or noises that are probably at 100 hertz. Now, what happens is that if your leak range on a plastic pipe is probably, say, at 50 hertz, and your hearing is damaged and you can't hear anything below 100 hertz, you will not hear that leak. Full stop, you will not hear the leak. No question, no ability. Same as if it's a high range leak noise and your hearing has been damaged, you can't hear the high noises, you're not going to hear the high frequency noises either. Consequently, now, I always say, when we do any leak detection projects anywhere in the world as Mia Water, we always do hearing tests of the leak detection staff. Because if you don't, and you're going to employ deaf people, they are not going to be able to find leaks. The other thing is the ability of a male to a female. The female's hearing is far superior to a male. So generally the best leak detection engineers you have are female and younger females, not the 60-year-old females, because they are losing their ability, but the 20, 30-year age people, good hearing, not damaged by concerts, female, they are your best leak detection engineers to find leaks. And the best ones I've seen and worked with have always been females. So very simple thing, we came up with a scenario that leak noise is pressure reliant. When you're thinking, wow, we know that. We just had to put it in writing that we know that leak noise is pressure reliant. Higher pressure, better leak noise. So what happens is, a common technique is what we use anywhere in the world, is we go around the mains, fittings or house connections, listening for leak noise. But the age of the user or the ability of the user, we don't monitor. We just recruit somebody to go to do leak detection. And generally the people that are recruited for leak detection are people that are been in the old days, either digging a hole, or we just find somebody from an agency and put them into leak detection jobs. And we do not know if they have the ability to be able to hear the leaks. So that's one of the things we found on some projects. And this case study looks at the leak noise transfer in non-metallic pipes. And what I found on a project that I completed, done some work in Canada on it, did some work in the US on it, the Caribbean islands did some work, and Asia did some work. And I found the same thing everywhere, the same results everywhere. And when we used an electronic microphone, the bottom line being pressure in the pipe in meters, and the line on the left is the distance between the fitting noise we heard from the stop tap. So we know how far away we heard that leak noise on a piece of pipe. So we're listening on a house connections. So we're listening on house connections, and we're listening to see how far we could hear a leak away by listening on a house connection or a valve. So we could see using an electronic device that if it was at 5 meters pressure, we could hear leaks 5 meters away. But when it was at 5 meters pressure, we didn't hear leaks 10 meters or 15 meters away. And when we got to 10 meters pressure, we could hear leaks up to 10 meters away, but we couldn't hear leaks that were 15 meters away or 20 meters away. And again, when we got to 15 meters pressure, we could hear leaks anything less than 15 meters away, and we could hear leaks up to about 18 meters away because the pressure was getting up. The same as on 20 meters, the maximum we heard was 24 meters away. But what you can see is that no matter what pressure, when we get to 45 meters pressure, which was in the Americas, we only ever heard a leak that was probably the maximum 28 meters away. So we know now that leak noise does not travel more than 30 to 40 meters on plastic. I don't know, we got into it. So this is what we learned on that. These are using an electronic microphone. When we use a manual stick, you can see that even at 25 meters, the furthest leak we heard away was only 12 meters away. Now this is compared to here, 28 meters. So on 25, there we could hear a leak 20, somewhere around this point here. Here on manual sticks, and the amount of leaks we couldn't hear a leak noise on. Now this is with a manual stick, and what we did, we listened with a manual stick and heard no leak noise, and then we'd revert back to the electronic listening stick and hear a leak was present. And what we're finding is, regardless of pressure, that if you're using a manual listening stick, when you start getting on average much more than 6 meters or 8 meters away, you will not hear the leak. So if you're listening on a house connection and you're listening with 10 meters pressure on a house connection, if the leak is much more than 7 or 8 meters away, you won't hear it. So we suddenly found out that, wow, manual sticks do not work because we're using the ability of the engineer to do it, and some can hear, some can't. So I'm saying, when we look at the relationship, you can see that the distance we could hear on the with the electronic ground microphone was about 28 meters, whereas only 12 meters with a manual listening stick. So you can see now that on a non-metallic pipe, don't use a manual listening stick. You can see the relationship was proportional until around about 18 meters. But you can, the story is you can see more leaks available, or listen to more leaks available with a manual stick. Sorry, an electronic ground microphone stick than you can with a manual stick. And what we found was a rule of thumb that for each meter of pressure, the leak noise will travel 1 meter in distance. So this is critical. For each meter of pressure, the leak noise will travel 1 meter in distance. So in this scenario, we have 3 fittings where you see the arrows away. Here we had about 4 meters pressure. So we knew we could listen on each of the arrows, and we knew we could hear a leak on the mains pipe as well, because they was all within 4 meters of each other. This one here, the same area, about 4 meters of pressure. We knew here we could listen on the house connections with an electronic device, and we would, if there was a leak on the service pipe, the main pipe, we would hear it because we was always within 4 meters of a connection. In this area here, we had about 8 meters pressure. But here we knew that if we just listen on a house connection, the distance of pipe between the house, each house connection was greater than 8 meters distance. So we knew we would miss a leak. So this is what we learned, that we have to look at the pressure in the pipe. And if the pressure in the pipe is 4 meters, leak noise will travel 4 meters from that fitting. So if you're listening on a house connection at 4 meters pressure, the furthest leak you'll hear will be 4 meters away. So if there's a leak 5 meters away, you will not hear it. So when you're doing leak noise at night and you can't get a house connection, you cannot listen on mains fittings only. You have to listen on the surface. So listening on the surface, you listen every meter with a ground microphone. And this is what you have to do successful leak detection. So the best practice is ground microphone every 1 meter over the main and over the service connections. That is your best practice in all scenarios. It's slow, but the transmission of the leak noise to the surface isn't affected, as we know, we mentioned earlier on. As we said, do not rely on manual sticks for deaf people. Do not rely on manual sticks for any people. Electronic ground microphones. When you employ your staff, ensure they're not deaf. Complete a hearing test for all your staff. Work when your pressure is highest and your background noise is lowest. These are all simple things. But with that, I hope you've learned some things. I hope you've got some ideas of things. And I hope you've understood a lot of what I spoke about. So thank you.
All right, thank you so much. All right, and Stuart has been very direct to say how difficult leak detection in Asia could be because of our pipe materials, water pressure, and other factors and scenarios making leak detection really challenging. And I agree with Stuart that we are not superheroes to easily scan the pipes and, find right away where the leak is. And not all the noise we hear during the leak detection doesn't mean it is already a leak noise. So leak detection is indeed tricky. That's why having knowledge with leak detection, with the devices available, and also having experience is really needed, because leak detection is very important first step to towards stopping the leakage to achieve long-term and sustainable reductions in NRW. So, on behalf of everyone here today, thank you so much, Stuart, for the opportunity to have you as our speaker. And we're very grateful for the time and effort you took to share your knowledge, the case study. You know, it's very interesting to know that female, younger ages, have better hearing capacities. So the best practices, which are mostly really based on your experience in leak detection. So again, thank you so much, Stuart. So for everyone, we will just have a very quick break. We'll just have 5-minute break, and please add your or type in your questions in the Q&A button that you will see on your Zoom's control panel. So after the break, we will proceed to our question and answer. All right, everyone. So now let us proceed to our question and answer portion. All right, so let me read the questions here and just continue to type in your questions. Again, questions that will not be addressed during our 15-minute question and answer portion will be addressed together with on our website. That will be wherein you will also see the presentation slides and the recording for this webinar. So let's start with the question coming from Edward Agbay. Leak detection that you have discussed are mainly focused on the main lines. Is there another approach if the leaks are found at the service connection from tapping point to water meter? Or are these applicable also for service connections?
Yeah, if you look at that, the answer to that is that in reality, the process doesn't change. That, as you said there from the case study, the leak noise will travel 1 meter distance for 1 meter pressure. So if you listen on the meter connection and the pressure in the main is too low, that you're only going to travel 2 meters, you listen on the surface every 1 meter with a ground microphone. So in reality, it doesn't matter if you're on a service connection or a main, the process or the basic process remains the same, and you do not change methodologies. Not in the first instance until you start to get more advanced and more clever. So always start at the beginning.
All right. Thank you for that, Stuart, and I hope we're able to address that, Edward. Now let's go to Christine Acosta's question. What is the effect of correlating in pipeline where there are 2 or more pipe material connection?
Okay, so if you've got 2 different materials in a pipeline, and you measure and you don't know what their materials are, and you're just putting the measurement between the 2, and you put it all in 1 material, the velocity will be wrong, so therefore the formula will put you in the wrong position. If you know the positions of the pipe changes and the materials, you can put multiple materials in the correlator. So you can put 3, 4, I think up to 6 materials in a correlator to do that, and it will take into account all them different materials. Or this is where we go advanced, and this is where we don't want to get there on this session. You can do in bracket or out of bracket velocity checks, which is another thing. But yes, you can do it with a correlator. There are the abilities to do it, and if you don't know where the materials are or the materials, you can do velocity checks, which are inside or outside velocity checks. Or I can talk to you offline with a much simpler method as well, a different method, but it all comes with experience, but the correlators can account for that.
All right, thank you for that, Stuart. Now let's go to the next question from Paulo Balagso. What is the minimum pressure required to have a good quality leak noise?
Look, what is the minimal pressure to have a good quality leak noise? Okay, if you had 100 meters pressure, be perfect, but we don't. So in reality, it's the pressure. You have to put in your head, think in your head now, the leak size, the leak type. If I've got 50 meters pressure and I have a hole in the pipe, the leak noise won't be very good because I've got a hole of 100 centimeters. So water's just going to flow out. It's all to do with the size of the leak, with the material and the pressure. So if you've got one at 3 meters pressure and a very small pinprick, that will leak with a noise. If you've got 3 meters pressure in a hole, the water will just flow out. So there's no such thing as a minimal pressure. It's pressure and the size of the leak or the type of the leak you've got to look at. So you have to start looking at, it's not just one answer. I can have 5 meters pressure and a little tiny leak and I'll get good noise. I can have 20 meters pressure and a big leak and I get no noise. So I hope that explains that pressure isn't the critical bit. It's where you're listening to, because if you're listening 10 meters away from a leak noise and you only got 5 meters pressure, you're not going to hear that leak whether it's good or bad anyway, because you're too far and the leak noise can't travel down that pipe for you to listen to. I hope that explains the question, but yeah, I hope it explains.
Sorry, I was on mute. So thank you for that.
Yeah.
Really a lot of factors to consider. So next, Ramon San Jose, how are we able to determine the location of the leak or limitation of its distance based from the pressure by using listening stick or ground microphone? Is it based on noise logger's result or based on experience?
Determine the location of the leaks. Basically, it was done in the field. The information come from field activities, and we created different scenarios. So when we went there and we found a leak, and I was present on many of these, probably 90% of these leaks. So when we went there and we heard a noise, we would listen with a manual stick, and then we would put a team back in the same area the following day or later that day with an electronic listening stick. And we would learn what they couldn't hear with the manual stick that they could hear with the electronic stick. And then at the same time, we'd pinpoint the leak position from the leak noise and we'd measure that distance. And we soon got to learn that when we heard a noise, that if we had 5 meters pressure, the leak noise was normally found within 5 meters. We then went into the area and ground microphoned every 1 meter and found even more leaks in the system. And what we learned then was that some of these leaks were 10 meters away from any service connection or mains pipe. So when we listened on the surface connection, we couldn't hear a leak noise. When we listened with the electronic stick, we couldn't hear a leak noise. But when we listened on top of the main, we could hear a leak. And that's when we started to learn that the distance for the leak noise to travel down the pipe was further than the pressure in the main, which meant the leak noise, we couldn't hear it. So it is all based upon field tests, just live field tests. And it's a rule of thumb, but basically it's to say, don't do leak detection listening on mains fittings only if you've got 5 meters pressure, because you will not hear leaks. I hope that answers that question.
Thank you. Now let's go to Bala's question. How can we eliminate background noise? Is that any device is available in market to eliminate such noise?
If you have an electronic listening device, you do have filters within the device that you can, because you wear headphones with the electronic device, the noises to the headphone, and you can filter out various noises. So you can have the ability to filter out background noise, to only listen to leak noise, provided you know the frequency of the leak noise. Because if you're not careful and you're not experienced, you may filter out the leak noise and just leave the background noise. Now, the easiest way to understand this, if you have an orchestra and you have the drums playing, the guitar playing, the trumpets playing, the saxophones playing, and you just want to hear the saxophone, they're all on different hertz ranges. The trumpet, the drums, they're all on different hertz ranges of sound. So you can block out the hertz range of the drums, and you can block out the hertz range of the trumpet, and you can block out the hertz range of all the other musical instruments, and just listen to a saxophone, provided you know the noise of the saxophone. But if you don't know what noise the saxophone makes, you may block out that noise and be listening to the trumpet. This is the same with leakage and background noise. If you start playing with filters and you don't know what you're eliminating, you may be turning off the leak noise not knowingly. So again, you have the ability, but this is all when you're experienced and several years down the road. And for me, I do not use any filters. I let my ears do the filtering and put the noise. And the way to do leak detection, you have to put in your head the picture. So you listen to a noise, and then you have to put in your head the picture. What does that noise sound like? Does it sound like a leak with a stone rattling about? Do I get the leak noise? And then does it sound like a leak? Or can I put the noise with a picture? And if I've just got this which is electrical noise, you're thinking, that doesn't sound like leak noise. It doesn't, I can't put a picture in my head to match that noise. So I don't filter anything. I let put the picture in your head of what you're looking for and see if the noise can match that picture. And if it doesn't, it's probably not. So again, a long answer, but I hope that helps.
Yes, very helpful indeed. Thank you. Now we have your question with 2 likes. Hi, Stuart. This is from Roberto Junior Tabines. So what is the acceptable leak detection hit rate in percentage to know that we have a good leak detection team?
Okay. If you have 5% of dry holes, if your dry hole is down to 5%, you're doing very well as a company. If you're at 5%, you need to understand what them 5% of dry holes are, which means dry hole means where you dig a hole and there's no leak found. Now, if they dig a hole with no leak found and they find an obstruction in the pipe there, the obstruction is causing the noise. Now, bear in mind, we don't have X-ray vision. We're looking down a road with a tarmac road or a concrete road, and we've got to put a cross on the ground. Now, they have to do everything possible, and it's not a question, what they need to understand, it's not a question to say, I've got a leak noise here, I've got a leak. When you find that leak noise, you have to do everything you possibly can to say it's not a leak. If I can't say it's not a leak, well, therefore it must be a leak. Now, 5% is very good, but you also have to understand that if somebody's hitting 25% dry holes, you've got an issue with training. If they're not hitting any dry holes, they're either very good or they don't put in the difficult leaks. If you don't put in a difficult leak, you'll never get a dry hole. So you walk away from leaks because you're not sure, rather than get a dry hole. So it's good to understand, but for me, when acceptable was 5% was an acceptable range, as long as it wasn't the same teams. So you have to look at your teams of why they're doing it as well. And don't just walk away from a dry hole. A mistake, don't walk away from. Use that mistake to go back to find why you got a dry hole. And don't condemn them for hitting a dry hole, because otherwise they will not put a difficult job in again. So if you penalise them, they won't put you a difficult job in.
Mm-hmm. All right, thank you for that. And now, this might be the last question for this webinar. You know, again, we'll ask Stuart's help to answer all the other remaining questions, and that will be available on our website. For the last one, question from Joff Matriano: how often should we carry out leak detection in a DMA? Is there a rule of thumb used for staffing for leak detection? For example, the land pipe technician.
If you're looking at a DMA, you basically, if you look at your DMAs, you put a league table and you create a league table of your performing DMAs. And the top DMA is the worst performing, and your best DMA which is the bottom of the list, is your best performing. So you always look at the top performing DMAs, as in the worst performing. So the top of your list is the worst performing DMAs. They're the ones you start at first. And then there's 3 or 4 different approaches. So that's ones you look at first to start doing your leak detection. And you calculate in there, and you have to have key performance indicators to understand why you're going to go into that DMA. You need to understand, if don't understand just on volume, because if you only go on volume as alone, as a key performance indicator, and the area is very big, you're going to go there for the wrong reason. So you put volume per kilometre of main. And therefore, now you know everybody's now on the same level. And then you create that volume and look at pressure. Because if it's a high pressure area, the leaks are going to leak more. So therefore, that's the different characteristic you need to put in. So I've got some very simple spreadsheets I can share with my people. I'm friends with him anyway, I think on LinkedIn or Facebook, Joseph. So I can share with him a very simple spreadsheet that is only done in Excel. But if you look at length of mains per technician, what you look at as well, a technician should do between 3 and 5 kilometres a day if they're just walking the mains. Depending on the technique they're adopting, if they're doing every service connection, you may be down to 2 kilometres a day. You have to look at the weather. If you're in a rainy period and they're not going to be able to work in the rain, they may do 1 kilometre a day. If you look at the heat, some of the areas we moved their working timetables from, I think starting at 8 or 9, we started them at 5, and we made them work, or we asked them to work from the hours of 6 till lunchtime. 6 in the morning till lunchtime. And we found that was better for them. They didn't work in the heat of the day. We got more distance out. So if you get 2 to 3 kilometres a day out of a technician, you're doing well. But look at your reasons of why they're performing well or not performing well. And don't tell them, I was on one project, they had to do 5 kilometres a day. You don't want quantity, you want quality. So as soon as somebody do 1 kilometre a day with excellent quality, getting every leaks, then say you've got to do 5 kilometres a day, and they just whip through the area very quickly and give me nothing back. So there's lots of key performance indicators you have to understand before you make a decision.
All right, thank you.
Everything sounds complicated. It's not. It's very simple.
Yeah. So, but then thank you so much, Stuart, for answering those questions, and really for giving us this opportunity to hear from you and learn about leak detection. So thank you, and please stay tuned because I'll be calling my colleague Jimé, and she will let you know more about especially the certificate and where you can get the copy of this presentation. Thank you.
So should I start? Hi everyone, I'm Jamay. I am part of the marketing team. I will just show a few slides before we end this webinar. But first of all, we would like to thank everyone for taking the time to attend our webinar. So we would, sorry. So we really hope that you have learned a lot from our guest speakers who share their ideas and expertise in this field. So for the next one, wait, I'm having trouble with my screen. There you go. So we sent out different survey forms to your email. So it will cover the previous webinars, and we will also send for previous topics for us to help us to improve our webinars for the future reference. So just in case to miss our previous webinars, our webinar videos will be available on AGA Marketplace website. Just visit www.aga-marketplace.com. So you can watch there the 3 videos, and you can also download the presentation and can check out all the Q&A portion. So there. We will also send out certificates to everyone. You will receive it via email. So we will also include here all the topics that you have attended and completed. So next one. This is the AGA Marketplace. Feel free to explore our different offerings on AGA Marketplace about water and wastewater services and different products. So just let's stay connected, and don't forget to like and to follow us on LinkedIn and Facebook. You can see our accounts on your screen. So again, thank you everyone for taking the time to attend our webinar. So definitely this is not going to be the last one. So stay tuned, and thank you and God bless. I think that's it.
Yes, thank you, Jermaine. Thank you, Stuart. And thank you, everyone. Happy Friday. Happy weekend to all of you. And be safe.
Thank you very much, everybody. Hope to see you all again soon.
Sure. Thank you.
Thank you.